So now let's talk a little bit about what are the types of sub problems in each of these broad paradigms, and then I'll give you a lot of examples and we can figure out for ourselves whether which of these broader paradigms that problem belongs to. In supervised learning, you have multiple problems like classification, regression, ranking, and so on. Broadly speaking, classification is the problem where you are learning to classify an input into one of a finite number of labels. What do I mean by that? For example, when an email is given, which is the input, we want to be able to say whether this email belongs to one of a finite set of classes, whether it is a legitimate or a ham email or an illegitimate or a spam email. There are only two classes there that every email can be categorized, or we wish every email to be categorized as, and that is how the supervision is also given. When there are only two classes, then that problem is often called as a binary classification problem. Binary stands for 2, and when the number of classes, the number of labels that you have is just 2, it's a binary classification problem. Now, there can be situations where you want to classify an input into one of more than two classes. Now, can you pause and think of an example where you have some data and the number of classes is strictly more than 2? I will give you an example. One example would be a digit recognition problem that we just discussed, right? So, you might have lot of inputs, right? So, maybe you will have input like this of images of written digits which are taken as images, and then you might have corresponding labels, and how many different labels are possible. Obviously there are 10 possible labels corresponding to 10 digits from 0 to 9, right? So, and now given a new image, we want to learn what digit that this image represents, right? So, and that is a typical example of a multi-class classification problem. Well, ordinal classification is another type of multi-class like classification problem. For example, let's say you are told in your data a lot of movies that you have watched, and then there are some features for these movies, let's say that describes who are the actors of this movie, what is the genre of this movie, and whether it's a what is the language of this movie, whether it's a Hollywood movie, Bollywood movie, whatnot, right? So you might have a lot of features to say what to describe these movies, and now the label could be how many stars that you rated this movie as, an average customer rated this movie as, right? So let's say there are stars 1 star, 2 star, 3 star, 4 star and 5 star, and now we will look at the average of let's say 10,000 people who rated this particular movie, and let's say if you look at IMDb ratings and so on, right? So they are average ratings of people who have given manual ratings for these movies. Similarly, you might have stars, right? So let's say Netflix used to have these stars. Now let's say a movie is rated 3.75 stars. Another movie might have been rated 4 stars, right? So for now, for ease of discussion, let's say these stars are one of 5 different values, right? So 1 star, 2 star, 3 star, 4 star or 5 star, right? So every movie is rated by somebody as one of these numbers. And now given a new movie, we want to say what is the star rating that we expect for this movie to be, right? So this is useful because, for example, if I as an individual who watches movies on some OTT, let's say Netflix or Prime or whatever your favorite OTT is, I let's say go and give the star ratings to 150 movies that I watched. Now the OTT platform is trying to recommend movies to me, which means that the OTT platform has to solve the problem, given a new movie, what rating would I give for that movie? And now based on that, if the rating is high, if it thinks my rating would be high, then the platform would recommend that movie to me, because I am more likely to watch that movie and I am more likely to click and watch the movie, which means that I am more likely to be satisfied with being on the platform. And of course OTT platforms want to keep me as engaged as possible in their platforms. So now it looks like a multi-class classification problem, right? So because for every movie I have to decide whether it is one of 1 star, 2 star, 3 star, 4 star or 5 star. Now, why do we say it's ordinal classification as opposed to multi-class classification? Well, there is a subtle difference, right? So, the subtle difference comes in the way mistakes are treated, right? So, with that information, can you pause and think what would be the difference between multi-class and ordinal classification in the way mistakes are treated? What would I actually mean by that? I'm going to tell you what I mean by that now. For example, right, so if in the multi-class classification of a digit recognition, let's say I give you a digit and then I ask you to say which digit this corresponds to, right? So, which digit this image corresponds to, let's say, right? And now maybe the truth for this is 7, okay? And now what your algorithm predicts based on its learning, let's say, is 1, right? Now this is a mistake. Now let's say this is a pin code, part of a pin code, right? So, and then I have written my pin code manually, and then you want a computer to figure out what is the pin code so that the letter can be routed to that particular pin code, right? So, that let's say that's the use case we are looking at, which means that I need to figure out what number is actually written on it, correctly. Now, if the true number that was indicated, that was intended is 7, but then if the computer thinks of it as 1, then let's say this is 600712, right? So, let's say that was the original pin code, but now my computer, let's say it gets all these things correctly, it would think it is 600112, because this 7 got mispredicted as 1. Now, that is a mistake, and this is a costly mistake, right? So, now let's say instead of predicting it as 1, let's say here is another algorithm which predicts it as 6, which means that I am going to think of my pin code as 600612. This is also a mistake, and this is also a mistake, this is also a mistake, because I am going wrong on the 4th digit, and these two mistakes are equally bad, which means that I am going to anyway route the letter to a wrong pin code, right? So, instead of 600712, I would either route it to 600112 in the first case, or I would route it to 600612 in the second case, both of which are incorrect things, and they are bad, equally bad. Now, on the other hand, if it's the Netflix movie prediction rating problem, the star prediction problem, let's say there is a movie, right? So, some movie, right? So, let's say Titanic is the movie which I have not, let's say, watched, right? And now I want Netflix to figure out or Prime to figure out what would be the star rating I would actually give for Titanic had I watched Titanic, right? So, let's say if truthfully, right, so if I actually watch it, I will give Titanic 5 stars, right? So, I really, let's say, like the movie a lot, and I would actually give it 5 stars. Now, let's say there is an algorithm or a method that predicts this as 1 star. Now, that means that that OTT platform is not going to recommend Titanic to me because it has incorrectly predicted this. Whereas, let's say there is another OTT platform which predicts it as 4 stars. Both of these are mistakes. They don't actually represent the truth. The truth is 5 stars, right? So, the first algorithm or the first OTT platform tells it's 1 star, whereas the second OTT platform tells it's 4 stars. Both of these are mistakes. But as opposed to the digit classification problem where you make a mistake, all mistakes are equally bad. Here, that's not the case, right? So, if I predict it as 4 star, then I am still closer to the truth than I am predicting it as 1 star, right? Still, I am thinking that the platform is thinking that I would actually enjoy Titanic as a movie because it thinks that it's 4 star, right? So, I would rate it as 4 star, as opposed to this, which would think, I will hate this movie because it thinks that I will give it only 1 star, right? So, which means that there is a possibility that the Titanic might show up on my feed for this platform, OTT platform, whereas for this platform it won't, which means that this platform is going to do it better. Now, the fundamental difference that I am trying to point out here is that there is an implicit difference in the way mistakes are measured in ordinal classification, and the reason why that happens is because there is an implicit order in the labels themselves, right? So, 5 star is the best. 4 star is closer to 5 star than 1 star. Making a mistake of 4 star for 5 star is better than making a mistake of 1 star for 5 star, because there is an ordering for in the labels. Whereas in the digit recognition case, it's tempting to think there is an ordering for the labels, that 1, 2, 3, 4, 0 to 9 has an implicit ordering, but then in terms of mistakes, that ordering doesn't really make sense, right? So if it is a mistake, it's a mistake, right? So all mistakes are equal, right? So and that's the subtle difference between ordinal classification and multi-class classification. Of course, there are other techniques, other methods of classification called regression, ranking, and structured learning. Regression, I will talk just about regression in this case. Regression is an example where the labels are not finite, right? So for example, in all the examples that you have seen so far, spam classification or digit recognition or Netflix stars prediction or movie star prediction, the number of possibilities that I am trying to predict from, right, so are finite, right? So in the spam classification, it's 2, in the digit recognition, it's 10, in the movie star classification, it's 5, right? So 1, 2, 3, 4, 5. Whereas there are problems where this number is not finite, it might be infinite. For example, let's say I want to predict how much will it rain tomorrow, right? How much is the point, right? So I'm trying to use features such as temperature, air precipitation, etc., all climate related or weather related parameters as input, and I have a huge data where for every single day in the last 10 years, let's say I have collected all these information, and now I also have an associated label which tells me the amount of rainfall that a particular place received. For example, it could be 100.2 centimeters, 7.8 centimeters, right? So in some units you measure the amount of rainfall, but then the number of possible labels is not finite. It can be any real number, any positive real number in this case, and when that happens, we call such problems as regression problems, which means that for a new day, let's say in the morning, I measure the air temperature, pressure, precipitation levels, etc., etc. I should be able to predict a number which tells me what is the amount of rainfall that I expect by, let's say, 6 p.m. on this particular location, right? So when the label is a real number, then we call this as a regression problem. Another example, which is a standard example, would be house price prediction, right? So let's say depending on the features of a house, which area the house is in, how many bedrooms are there in this house, what is the number of square feet, these are the features, and then what I want to predict is the price of this particular house, right? So the price is a value, and it is not necessarily one of finite values, right? So it can be 10,25,835, right? So that might be one particular prediction I might want to make, right? So there are so many possibilities in this case, and so I mean in general it's a real number. We can treat this as a real number that I am trying to predict, and when I do that, such problems are called as regression problems. There are some ranking problems, there are some structured learning problems which are also part of supervised learning. We won't really talk about that, but I just wanted to indicate that supervised learning goes beyond just classification. There are other problems as well.